Hello everyone, welcome back to my YouTube channel. So today I'm going to discuss a question that I've taken from a Pathfinder topic, ray optics. Let's read the question first. A laser beam propagates through a spherically symmetric medium surrounding a metal sphere of radius 10 cm. Refractive index of medium varies with distance small r from center O of the sphere according to law. Mu is proportional to small r, where my small r is very greater than capital R. Capital R is my radius of a metal sphere. A laser beam makes an angle theta which is equal to 30 degree with radial line point P, which is r0 centimeter away from O. What minimum distance from surface of sphere can beam reach? Which is having a radius equals to 10 centimeter, and this is placed in a spherically symmetric medium. Okay, so it's placed in a spherically symmetric medium, okay, whose refractive index is varying according to law. Mu is proportional to small r, where r value is very greater than radius of a sphere, and the laser beam is directed at angle 30 degree at point P. So I have to find a minimum distance from a surface of sphere can beam reach. Okay, so here you see the figure is very magnified view, but in actual the metal sphere will be acting like a point object, right? And the laser beam is very far, okay, somewhat like this. Okay, because it's given in the question the radius of a sphere capital R is very small, smaller than small. Okay, so this assumption I have to take into consideration. Okay, let's proceed. Okay, so here the question it was given that this was my metal sphere, okay, and its radius was capital R, and this blue circle that you can see, that I have tried to represent a varying refractive index according to law. Mu is proportional to small r. Actually this refractive index is varying continuously, but for easy understanding I made a circle so that you can visualize it in a better way, right? Actually there is a continuous variation in the refractive index. Okay, since my mu is proportional to small r, I can write it as mu equals to some constant times small r, right? That means, and this small r is measured from center O of a metallic sphere. Okay, that means more we are closer to the metallic sphere, less is the refractive index, right? So let's say refractive index of this lighter blue circle is mu1, mu2 and mu3. My mu3 value will be greater than mu2 value greater than mu1. Okay, as we are moving far away from center of a sphere, my refractive index will keep on increasing. Now it is given in the question from distance r0, okay, from distance r0 a laser beam was directed, okay, somewhat like this, okay, at angle 30 degree, and this was my theta at point P. What is happening in the figure is that laser beam is trying to move from higher refractive index to lower refractive index. So I can see that laser beam is trying to propagate from denser medium, right, denser medium to rarer medium, right? As we are moving closer to the center of a sphere, the distance is getting minimized from the center of a sphere. My refractive index of medium keeps on decreasing, right? So I'm moving from denser medium to rarer medium, I can say this, right? So what will happen, there will be continuous bending of this light laser beam, right? Okay, so there will be a some point in time the laser will go and reach a critical angle value, right? So at the point when the light will reach its critical value, right, when my angle of incidence will reach critical angle value, at that point in time my angle of refraction will be equal to 90 degree, right? Okay, so this angle, if you see, will be equal to 90 degree, and I know that normal drawn from a point to a curve, right, is my shortest distance, right? That means what I want to say is that when angle of refraction reaches to 90 degree, right, that will be the minimum distance from the metallic sphere, right? Okay, so this is the point that we have to keep into consideration. Okay, let's name the point. Let's say this point is Q. Okay, P and Q. Now if you see, actually this metallic sphere is like a point mass, and these distances are very far. Okay, okay, somewhat like this. So this was a magnified view for easier understanding, but if you actually see, situation is somewhat like this. So here metallic sphere is acting like a point mass because in the question it was given radius of a sphere was very less than small r, right? So if you see trajectory of a laser beam, this part from P to Q can be assumed to be a straight line, right? So if I join this P to Q, and this was my O, becomes a triangle, right? So let's say this angle crossing point P, the angle of refraction is my theta 1. So this was my theta 1, and at point Q it's 90 degree. Okay. Point P and point Q are very close, so I can assume refractive index at point P will be equal to refractive index at point Q. So this assumption I have to take into consideration, okay, to solve this question. Okay, if I apply Snell's law at point P, I can write mu of R naught times sine 30 degree is equal to n1 sine theta 1. Okay, so where my n1 value, I am taking refractive index of medium just after crossing point P. Okay, so if you see in the figure, this was my R naught value, and I am taking this distance from O to Q as my R minimum. Okay, so refractive index at point Q I can take to be mu of R minimum. Okay, so n1 value I can take mu of R minimum because point P and Q are very close. Okay, that's the catch of the question is. Okay, now I can apply Snell's law and write this equation. Mu R naught can be written as A times R naught because my refractive index mu is equal to A times R. So A R naught times sine 30 degree is equal to mu of R minimum times sine theta 1, okay, which is nothing equal to A times R naught sine 30 degree. Mu R minimum is A times R minimum times sine theta 1. So A cancel. There are two variable r minimum and sine theta 1. I have to find a relation. Now if you see in this triangle, applying sine law, I can write r minimum upon sine theta 1 is equal to r naught upon sine 90 degree, right? That implies I can write sine theta 1 is equal to r minimum upon r naught. Sine 90 is 1, right? So if I plug in this value sine theta 1 in this equation, I can write r naught sine 30 degree r minimum times sine theta 1, and that value is r minimum upon r naught, right? Let's cross multiply this. So this becomes r square naught sine 30 degree equals to r minimum square, right? So I was required to find r minimum. So r minimum value is r naught square root of sine 30 degree, right? R minimum value is r naught sine 30 is half, so its square root of half is 1 by root 2. R naught value, if you see, that's given in the question. R naught was equal to 50 times square root of 2. So if I put it here, so my R minimum value is 50 times square root of 2 divided by square root of 2, square root 2, square root 2 cancel, which is equal to 50 centimeter. But this R minimum value, if you see, was a distance from a center of a sphere, and my radius of a sphere is capital R. So my distance from sphere surface is equal to R minimum minus capital R. So that's 50, and my R capital R was 10, so that's 40 centimeter. So my 40 centimeter is the answer. Okay, so in this question, the real game was in taking the correct approximation.